Alright, fasten your seatbelts, folks. We're going to take a look at graphing tangent and its transformations today. Yes, we're going to try and get through all the transformations here. We'll see how it goes. So bear with me here. Alright, so we'll start out like we did with sine and cosine, where we're just going to graph the basic graph of tangent of x. Okay? Maybe you already looked at this in your graphing calculator. If you did, I hope you made sure you checked your graphing calculator set to radians instead of degrees here. But anyway, let's see what's going to happen. So I went ahead and made a table here. You'll notice that I kind of like left this inexplicable blank space here. You'll see why in a second. All right, but for right now, we'll go ahead and start at 0 and go out to 2 pi. I went ahead and selected specific values here. You'll see the halfway point pi. You'll see the quarter points pi over 2 and 3 pi over 2 like we normally talk about for sine and cosine. I also went ahead and did all the pi over 4s, all the reference angle pi over 4s. So pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. I did include the pi over 6s or the pi over 3s. You can put those in there if you want to. They're going to be irrational numbers, so I just wanted to stick with stuff that's going to give us nice numbers. So anyway, we plug in 0. Okay, now remember to evaluate tangent, okay, at 0, right? Well, so here's 0 on our coordinate plane, our unit circle stuff. But the problem is, remember that the x-coordinate is associated with cosine, right? That's cosine of 0. And this right here is sine of 0. So how the heck do we find tangent? Remember the tangent, though. Tangent is sine of x over cosine of x. So if we want to find tangent of 0, that would be equal to the sine of 0 divided by the cosine of 0. Okay, so what are they? Well, if we go back up to here, sine of 0 is 0 over cosine of 0, which is 1. And what's 0 divided by 1? Well, it's just 0. So no sweat there, right? And so we get 0. Okay, then we can plug in pi over 4. Okay, tangent of pi over 4 is, again, sine pi over 4 over cosine pi over 4. I'm not going to write all these out, but I'll just do a couple here. What's sine of pi over 4? Well, now we can use our reference triangle right here, okay? And sine is opposite over hypotenuse, so root 2 over 2 over 1. So just root 2 over 2, right? What's cosine pi over 4? Cosine pi over 4 is, well, again, adjacent, root 2 over 2 over 1. So that is, again, root 2 over 2. And we're dividing something by itself, so it gives us just 1. All right, and so this gives us 1. All right, now let's see what happens here with, I'll write out one more here. We'll do pi over 2. Now, at pi over 2, it's sine over cosine. And so let's see here. So again, at pi over 2, sine is 1, cosine is 0. So it's 1 over 0 here, which is, what's that equal? Well, if you try and type it in your calculator, or you might remember from our rational function unit, right? When you divide by 0, when you divide a number that's not 0, when you divide that by 0, you get undefined. So we get 1 over 0 here, or undefined. Okay, interesting. All right. And so then for the rest of this here, let's see. So for the 3 pi over 4, we're going to get something very similar to pi over 4, except now we're in quadrant 2. Tangent's negative in quadrant 2, and so we end up with negative 1 there. Okay. And then at pi, tangent of pi is going to be 0. Okay. 5 pi over 4 is going to be negative, or no, positive 1. Sorry, positive 1, back to positive 1. 3 pi over 2 is going to be, again, undefined, because you're dividing by sine by cosine, and at 3 pi over 2, sine is negative 1, cosine is 0, so it's negative 1 over 0, undefined. I guess I could put negative 1 over 0 there. At 7 pi over 4, we're going to be at negative 1 again, because at 7 pi over 4, you're in quadrant 4, you're like right here, okay? And so again, sine will be negative, cosine is positive, so you end up with a negative tangent then as well. And then for 2 pi, well, we're back to what we have at 0, so it's just 0, okay? So let's plot this here. So let's see here, at 0, 0. Okay, at pi over 4 we have 1. At pi over 2 we're undefined. Now what should we draw here for undefined? Well, it's not always clear, however. Let's see what happens using our calculators. What happens as we get really close to pi over 2 on our graphing calculators. So real quick, I already have tangent typed in. Okay, let's see what pi over 2 is roughly equal to as a decimal. So about 1.57, we'll say. 1.571. So what I'm going to do then is I'm just going to approach that 1.570796327. I'm going to approach that very close. I'm going to try and get very close to it. So I'll do like 1.501 maybe. Okay, 1.501 will be very close, just a little bit to the left of it, right? So 1.501. Okay, 14. 1.502, a little bit closer because again there's 1.507. Okay, 1.50. Oops, I think I went the wrong direction there. Yeah, sorry. This is 1.5, 1.3, or 1.502. Okay, there it goes. 1.503. Okay, 1.507. Okay, so you're getting a little bit closer here, right? But as we get closer and closer to that pi over 2, our number, our y value there is increasing. Okay? In fact, let me just go ahead and do like pi over 2, but I'm going to subtract like 0.00000. So I'm going to subtract a teeny tiny amount away from it. And you can see here, look what happens. This is almost pi over 2, right? I subtract like a teeny tiny little amount away from it. And look how big that number is. We're going off to infinity. So if we have a value that's undefined, right, and from the left-hand side, or from a side, our function is approaching infinity, well, guess what that means? That means we have an asymptote there. Okay, we have a vertical asymptote. So we have an asymptote, okay, for this undefined behavior at pi over 2. Okay, so then 3 pi over 4, we're at -1. Pi, we're back to 0. 5 pi over 4, we're back to 1. And 3 pi over 2, another asymptote. And then 7 pi over 4, -1 again. 2 pi, 0. So what do we get? Well, if I kind of connect the dots here, this is what we're going to look like. Something like this. Okay. That is going to be our, our tangent graph there. Okay. So, now, you'll notice here I left some space, and that's because I wanted to actually get in the way we're typically going to graph this, which is not going to be from 0 to 2 pi like we did here. Instead, we're going to go from -pi over 2 to pi over 2. Okay, which will give us one full kind of piece of the tangent. This is going to be like one full tangent graph right there. One full, like, you won't call it a wave, but one piece that repeats. This is the piece that kind of repeats over and over again. I mean, you can kind of like see a repeating piece right here too, but I think it's more natural to kind of see it here between the two asymptotes and the wave, or the, the curve there. So anyway, filling the rest of this out then, at -pi over 4, we would have -1, and at -pi over 2, we would have, again, 1 over 0, or undefined. So this is the more typical way that I'm going to be setting these up. And asymptote at the -pi over 2, -1, 0 there, and so it's going to go down like that. Okay, so what's the domain? Well, that's a bit of a trickier question. Some of our x values can't work, some of them do work, so we'll have to skip that one for right now. We'll go to the range, though. The range is very clearly, well, it goes up to infinity and down to -infinity there. Okay, so it's -infinity to infinity. The domain, well, like pi over 2 doesn't work. So it could be like all x except pi over 2. But then also 3 pi over 2 doesn't work. But then also -pi over 2 doesn't work. Okay? And there's a pattern here, though, right? There's a difference of pi. So what you could do is, the more typical way of writing this is, how do we write an infinite number of things? Because there's actually, we could keep going, right? We could keep going in either direction here. So how do we actually do this? Well, one easy way to do it is just to say all x except x equal to pi over 2 plus k pi. K is an integer. This allows us to kind of create a generic formula for all the different x values that we have to restrict. Okay, we start at pi over 2, and if you add k pi, where k is a integer, so it's like integer multiples of pi. So if I add 2 pi to pi over 2, that's going to have an asymptote. If I add 3 pi to pi over 2, that's going to have an asymptote. If I add a -7 pi to pi over 2, that's going to have an asymptote. Okay, so that's the way we're going to describe the domain there. Okay, the period, well, in this case, the period goes from -pi over 2. This is going to be our normal period for tangent, -pi over 2 to pi over 2. Okay, that's how we're going to set things up. Not 0 to 2 pi. Remember, for sine, cosine, it's 0 to 2 pi. But for tangent, it's this -pi over 2 to pi over 2. So that's a subtlety that you have to remember. Also, the period length, well, what's the distance between -pi over 2 and pi over 2? Well, it's a total of pi units in length. So whereas sine and cosine, the length is 2 pi, okay, for a normal sine or cosine wave. Tangent repeats itself every pi. All right, let's get into some actual graphing here. I know I'm running up. I've done like 10 minutes already, but I'll be able to run through this really quick because it's stuff you guys have seen before. So, tangent. Let's tackle this, right? I see no shift up or down. I see no shift left or right, but I do see stuff inside the tangent there. That x over 3, we're going to put between not 0 and 2 pi, between negative pi over 2 and pi over 2, because again, this is tangent. Tangent has a different period. Now we just solve like we normally would. We'll multiply both sides by 3. We'll get negative 3 pi over 2 and 3 pi over 2. Okay, so I'm just going to go out to negative 3 pi over 2 over here, and 3 pi over 2 over here. And again, you want to find the midpoint, so that's easy, it's 0, and the quarter points. So halfway between 3 pi over 2 and 0, okay, well right here we'll say, it's going to be 3 pi over 4. Okay, halfway between negative 3 pi over 2 and 0 is negative 3 pi over 4. Okay, the starting point and stopping point will include your asymptotes. So we know the asymptotes are going to be right here. And if you don't believe me, you can plug the negative 3 pi over 2 and 3 pi over 2 into their function right there, and you'll get undefined. Let's plug in 0. 0 divided by 3 is 0. Tangent of 0, 0. 0 times 1/2 is 0. So we got a point at 0, 0. At 3 pi over 4, let's plug that in. 3 pi over 4 divided by 3 is just pi over 4. Tangent of pi over 4 is 1 times 1/2 is positive 1/2. And tangent of negative 3 pi over 4. Okay, so tangent of 3 pi over 4 was positive 1/2. Tangent of negative 3 pi over 4, if you think about your unit circle here, negative 3 pi over 4, whoops, is right here. Okay, and tangent is positive there. Oh wait, sorry. My bad. Plugging in negative 3 pi over 4, we're going to divide by 3. We get negative pi over 4. Negative pi over 4 is our reference, is our angle, which is right here. Okay, there's negative pi over 4 in the clockwise direction, which is going to be in the fourth quadrant. Tangent's negative there, so it's going to be negative 1 times the 1/2, negative 1/2. So we'll put a point right there. Sorry, it's kind of over that. And we just connect the dots, and that's about as accurate as you need to really be. Just kind of go through it there. Okay, well, voila, there's the graph. All right, let's try another one here. All right, this one I see again a horizontal stretch or shrink. Now we're shifting up 1, and we have a negative, so we're reflecting up across the x-axis. So I'll go ahead and draw that +1 again, like we did before. I'm going to draw my new kind of midline here. So this is where this is going to be like where our tangents zeros are in some sense. All right, but we'll go ahead and take that 1/2 x, put it between negative pi over 2 and pi over 2, because again that is the period for tangent. Okay, whoops, 1/2 x. Multiply everything by 2 to get rid of this 1/2, right? So we get negative pi and pi, like we have right here on the graph. Kind of move that 1 pi over a little bit more, just to make it even a little bit. Okay, so then again, asymptotes at negative pi and pi. The starting points, stopping points are a period. 0 is the midpoint, and then the quarter points would be negative pi over 2 and pi over 2. Okay. And so now we plug them in. 0. 0 times 1/2 is 0. Tangent of 0 is 0 times negative 1 is 0. Still +1 would be 1. So we're at 0. We have a point at 1. Now let's plug in pi over 2. Pi over 2 times 1/2 is pi over 4. Tangent of pi over 4 is 1. Negative 1 plus 1 is 0. So you get a point right there. Let's plug in negative pi over 2. Negative pi over 2 times 1/2 is negative pi over 4. Tangent of negative pi over 4 is negative 1. Times the negative 1 is positive 1. Plus 1 is 2. And so we connect the dots. And voila, there's the graph. Okay, and again, it continues on. Right, we would expect to have more of these go on and more of these go on this way as well. Okay, so on and so forth. All right, but this is the one. I want you to give us one full period for right now. All right, let's try one more here. I think this is the last one. Yep, okay, this one's got everything, okay? So, this is kind of written in a little bit weird way, but just understand here that this whole thing is inside the tangent right there, okay? So, we're going to put those between the negative pi over 2 and pi over 2. Okay, we'll multiply everything by 2 first to get rid of that 1/2 there. So you get negative pi less than or equal to, oops, that's not 3, it's supposed to be pi. Whoop. Okay, So we have x plus pi, and then pi, and now we're going to subtract everything with pi because those parentheses don't really need anymore. Subtract pi on every side, so we get negative 2 pi, like so. Okay, and so we're going to start here at 0, and I'm going to go to negative 2 pi, and again find the halfway point, so negative pi, and the quarter point, so negative 3 pi over 2, and negative pi over 2. Okay, and we are shifted up 3, so I'm going to go like 1, 2, 3. Okay, I'm drawing my new midline here. This is where our graph will kind of like shows our, shift up 3 there. Okay, negative 2 pi is our starting point, so that's going to have an asymptote. 0 is our ending point for our first full wave, so that is also going to have an asymptote. Okay, let's start with that negative pi in the center there. Negative pi plus pi is 0. 1/2 times 0 is 0. Tangent of 0 is 0 times 2 is still 0, plus 3 is 3. So negative pi, we get 3. Okay, let's plug in negative pi over 2. Negative pi over 2 plus pi is pi over 2. Pi over 2 times 1/2 is pi over 4. Tangent of pi over 4 is 1 times 2 is 2 plus 3 is 5. So 4, 5. So pi over 2, 5 right there. And then you could probably figure out what the pattern's going to be. Let's go ahead and plug it in. Negative 3 pi over 2 plus pi is negative pi over 2 times 1/2 is negative pi over 4. Tangent negative pi over 4 is negative 1. Times 2 is negative 2 plus 3 is 1. And hey, lo and behold, there's the graph. So again, you can kind of extend this up if we want to there. And just connect the dots like so. And voila, there's your graph. Okay, sorry guys, thanks for sticking with me. I'll probably give you, again, 2 of these just to practice, to try on your own. Tangent's a little bit different though. All right, so thanks. And I think we are going to have then a quiz tomorrow. I may decide to put a review for all the different trig graphs and stuff. I may do like one more day of trig graphing if you want to. I'll make probably a video for that, and then also I have a quiz up too. All right, thanks guys. Have a good day.